Namaskar. We are discussing properties of Laplace transform. I mentioned some of the properties which we will discuss. In the last lecture, we studied the first property, which was linearity property. After that, note, please write down second property. It is shifting property. It is also named as translation of ft. So the heading will be translation of ft or shifting properties. There are following two shifting properties of Laplace transform, which give the Laplace transform of a function derived from ft. This is the same function ft, same notation which we are considering under Laplace transform. In terms of transform fs of ft, so the notations will be same, function will be ft and transform will be fs. After that, please write down point 1, first shifting property. It states that the Laplace transform of the function exponential of kt into ft. That means our function is equal to e of kt into ft. Is small f within the brackets s minus k, where fs, same notation, is Laplace transform of ft, same function we are starting with, and k is any real or complex number. It can be proved in straightforward manner like this, which I will show you now. Since we know from the definition of Laplace transform, it is better you write this statement again. L within the brackets ft, L of ft हो गया, and on the right hand side 0 to infinity exponential of minus st ft into dt is equal to f of s. So this is what? Same the statement, or rather the definition of the Laplace transform. So we are beginning with this definition. Now please write down, we have according to the statement of first shifting property, Now the function is what? Function is equal to exponential of kt into ft. So we have to start with this function. So write down on the left hand side L of within the brackets exponential of kt into ft, and it will be like this. And on the right hand side write down 0 to infinity like this, exponential of minus of st into exponential of kt into ft into dt. So we are now taking the Laplace transform of this whole function, and its value will be equal to this quantity. And again write down this is equal to 0 to infinity exponential of minus of s minus k into t ft into dt. This is very simple. What we have done? We have written the exponential quantities into one single form. Here it was minus of st and kt, and here it is we have taken minus sign outside the bracket, and within the brackets we have written s minus k. So these two quantities are same. Way of writing is slightly different. Now what is this? From the definition of the Laplace transform, this quantity is equal to f of s minus k. So this is our left hand side where we have taken the Laplace transform, and we are beginning with this function. In place of ft, our function is this one. That is, it is multiplied by a quantity exponential of kt. So if this is our left hand side, and in place of the function, if this is the whole function, then on the right hand side we will get this quantity. That is, in place of the value fs, what we will get? We will get fs minus k. So what our shifting property states, that if the function is f, in place of the ft, if the function is exponential of kt into ft, then what will happen? Our transform will be changed. It will become, in place of fs, it will be f of s minus k. So this is our first shifting property, and this was our proof of first shifting property. So this proves our required condition. Now, in order to demonstrate this method of evaluating of Laplace transform, we will consider an example. So write down example. What we are going to do, we are going to find out the Laplace transform of the function, which is equal to, please note it, exponential of minus 2t into sine of 3t. That means our function here is equal to this one. Exponential of minus of 2t into sine of 3t. Using the statement of first shifting property, which we have proved just now, we will find out the Laplace transform of this quantity. As we have already studied, what is the Laplace transform of sine of kt? We derived a formula in which left hand side was equal to L of sine kt, right hand side was equal to k upon k square plus s square. We are going to use this formula now. So, to find out the value of the above given example, first we will solve it like this. In the left hand side, write down L of sine 3t. Left hand side will be equal to L of sine 3t. So, using the formula we studied earlier, its value on the right hand side will become equal to 3 over s square plus 9. And this is what? F of s. So please note like this. Means first we have derived the value of a part of the example, which is sine 3t. Now our next step will be on the left hand side. Write down L of, within the brackets, exponential of minus 2t multiplied by sine 3t. Like this. L of this quantity, initially our example was this one. What we have done? First we have solved the part of this function like this. So from the statement of first shifting property, we can write that this quantity will be this quantity will be equal to 3 of 3 divided by s plus 2, because now k is equal to minus 2. So s minus k will become s minus minus 2. So s plus 2. And its square plus 9. It is from this derivation. After solution, this will be equal to this quantity. That is 3 divided by s square plus 4s plus 3. So this is the solution of the example which we started with. So this was our